Hey, what's going on, guys? In this video we are going to see an example on source transformation technique, and here we are going to deal with this circuit a little bit differently, because if you notice, here we have two voltage sources, and also we have one dependent current source. Because of this dependent current source, we are going to deal with this one a little bit differently, and the question is asking what is the voltage across this 2 ohm resistor, or in other way, if you think about like this is a node and this is a reference, what is the voltage across this node and this reference. I'm saying this one like this because we are going to try to get rid of this 2 ohm resistor, so you have to know the voltage we are trying to find is going to be between these two nodes. Now let's go ahead and solve this one. Again, the source transformation is basically when we have current source and resistance in parallel, we can change this one into voltage and resistance in series. And when we have voltage and resistance in series, we can change that one into current and resistance in parallel. That's the basic idea of that one. And let's try to simplify the circuit. Let's start with this one. Let's start with this dependent current source. And what we can do right here is we can change this dependent current source into dependent voltage source by using V is equal to IR, right? Here the current is 0.25 Vx, so 0.25 Vx times 4, that's going to give us 1 Vx. So that's going to be our new current source, actually voltage source, I'm sorry. So voltage source is going to be that. Now let's go ahead and draw our new circuit. So here other things are going to be just same as it is. 6 volt, 2 ohm, and here we have this one, and okay, this is 2 ohm and plus minus V of x, and now we combine these two into series, so we are going to have 4 ohm in series and new voltage source. Since the current in this direction, we are going to put plus minus like this, and then we are going to have V of x right here, and then we are going to have plus minus 18 voltage, and that's it, right? Now we have turned this one into this one. Now another thing we can do is we can change this one into current and resistance in parallel, right? So we can do something about this. So let's go ahead and do that one. So if I want to change this one into current source, I have to use this one. I is equal to V over R, and V is 6, R is 2, so that's going to be a 3 ampere current source. So here we are going to have current in this direction, yeah, and this is going to be 3 amp, and we are going to have this 2 ohm in parallel right now, and then again we have another 2 ohm right here, plus minus V of x right here, and then here we have this 4 ohm and plus minus V of x, and then we have this 18 voltage. Okay, that's it. And now you can see that this 2 ohm and this 2 ohm in parallel. Now we can find the equivalent resistance for this one by using this method, like R2 by 2 divided by 2 plus 2, right? R1 times R2 divided by R1 plus R2, and if you do that, that's going to be 4 over 4, and that's equal to 1. So the equivalent resistance for these two is going to be just 1 ohm. So we can draw our new circuit using that. So this is going to be just still 3 ampere, and here we are going to have 1 ohm plus minus V of x, and then here we are going to have this 4 ohm, and then we are going to put plus minus V of x and plus minus 18 voltage. Okay, and that's it. Now let's see what we can do right here. Now we almost reached the end of this one. Now the next thing is we are going to do the mesh analysis. Now to do that one, what I'm going to do is I'm going to bring this 1 ohm resistance into like here. It's still parallel, but I'm bringing it here. Okay, I bring this 1 ohm to here, and then I'm gonna put a node right here, and this V of x remains right here, plus minus V of x. That's what we are trying to find. Okay, other things are going to be just as it is. Okay, plus minus V of x, and then plus minus 18 voltage, and that's it, right? Now I'm going to assign an artificial mesh. Okay, here what I'm going to put is I1, and also here I'm going to put I1, right? So in between we created artificial mesh for two of them. Now let's go ahead and solve this one. First mesh, we can see that this is going through this 3 ampere. I shouldn't have done this one. If I want to put this one right here, I have to turn this one into voltage. So actually source transformation here. So we know that I is equal to V over R. So V is equal to, if I want, here previously we had current and resistance in parallel, so we are going to put V is equal to IR. So this is going to be 3 times 1, and that's going to be, this is 3 ohm, actually 3 volts right here. I'm sorry about that, this is 3 volt. And this is plus minus 3 volt, and now it's correct, right? Now we have created the artificial mesh, and now we can go ahead and solve this one. So since we are going, this I1 is going from minus to plus, that's going to be a voltage rise. So we put positive 3 minus, here we are going to have a voltage drop, that's going to be 1 I1 minus 1 I1, and this is going through the V of x, plus to minus, that's going to be a voltage drop, so that's going to be minus Vx is equal to 0. So this is our first mesh, and if you simplify, that's going to be 3 minus I1 minus V of x is equal to 0, and this is our first equation from the first mesh. Now let's look at the second equation. In the second mesh, we can see that this I1 is going through minus to plus Vx, so that's going to be a voltage rise, that's going to be positive Vx, and then this is going through this 4 ohm, that's going to be 4 ohm, that's going to be a voltage drop, minus 4 I1, and then plus to minus voltage drop, so that's going to be minus Vx, and then plus to minus again voltage drop, minus 18 is equal to 0. Okay, let's try to simplify this one. Here we have Vx and negative Vx, so we can cancel both of them. Okay, and negative 4i1 is equal to negative 18. Therefore, negative 4i1 is equal to negative 4i1 minus 18 is equal to 0. So negative 4i1 is going to be equal to positive 18. Therefore, I1 is going to be equal to 18 over negative 4. That's going to be negative 4.5. Okay, negative 4.5 ampere. Now, since we are trying to find this V of x, we found out this is negative 4.5. Just plug it in this equation, and that's going to give us the final answer. So, and we know that this is 3. I'm using this equation, right? This is 3 minus, and I1 we found out that's minus 4.5. So minus 4.5, and V of x, I'm moving to the other side of the equation. V of equal to V of x. Therefore, V of x is going to be equal to 3 plus minus minus plus, so 7.5 voltage, and that's going to be our final answer. And that's how we use source transformation technique when we have problem like this. I hope this helps. Thanks for watching.